Hello, my name is Jahan Lu. I'm the leader of the Unified Database Group from Department of Computer Science, University of Helsinki. The general research goal of our group is to improve the efficiency and the usability of database management systems in the array of big data. There are currently two research topics in our group. The first one is about multimodal database, and the second one is on quantum database. Our goal is to build a unified database management system. I would like to quote the words from Stephen Hawking, who is a famous English theoretical physicist. He said, I think the next 21st century will be the century of complexity. We have already discovered the basic laws that govern matter and understand all the normal situations. We don't know how the laws fit together and what happens under extreme conditions. But I expect that we will find a completely unified theory sometime this century. It is an important job for theoretical physicists to build a unified theory for different physical laws. By ways of analogy, it is an important job for database researchers to build a unified theory for multimodal data. We have already developed different types of database, such as relation database, graph database, RDF database, XML database, multimedia database, but we don't know how those different databases can fit together. Our research goal is to find a novel, unified theory for the next generation database. The new database will handle the variety challenge of big data, including hierarchical data such as XML JSON files, graph data such as RDF, property graph networks, tabular data such as CSV, etc. The current theory of relations is not adequate to mathematically describe modern NoSQL and multimodal database. Therefore, it calls for a new unified data model and a theory for multimodal data. Our idea is to extend the relation model to categorical model and define a new collection of theory to handle multimodal data. Category theory was developed by mathematicians in the 1940s and has been successfully applied in many areas of science, including computer science. We will apply category theory for database from 4 directions. First, we will extend the entity relation ER model for modeling multimodal data by building a characteristical data model. Second, we will extend the relation normal form to handle different forms of data and propose category normal form. Third, we will extend the relation algebra to provide a unified algebra framework to query different formats of data. Fourthly, we will extend the relation calculus to define a predicate calculus for category data. Those 4 directions are our ongoing works. I now briefly discuss our second research topic on quantum database. The general field of quantum computing has experienced remarkable progress in the last years. The goal of our group is to develop the framework and the algorithm for quantum database. There are two levels of quantum computing approach for database. The first one is called the hybrid level. We solve classical database optimization and modeling problem with quantum computing, but the data are stored in a classical computer. The second one is called the quantum data level, which stores the quantum data qubit in a quantum database with QRAM. Then the main research problem is how to search and manage qubit data. For the detail of research on quantum database, well done. Zhentong will present the detail later. Finally, to summarize, the long-term vision of our research group is to combine three fields together, including database, quantum, and category theory, to build the next generation database. Quantum theory can handle the uncertainty of data, and category theory is useful for a unified model of multimodal data. Those three components may fit together to contributing the next generation database, both in practice and in theory. Thanks.